In this video, we're going to be covering an example of turning inside of Bobcad CAM. Now, I have a solid model, and this represents what I want to cut. Now, when we create geometry for turning, we don't actually use the surfaces. We need wireframe geometry. So the first thing I need to do before I can start toolpathing this is I'm going to come over here to the layers, right-click, and add a new layer. And I'm just going to call this layer Turn Geo for my turn geometry. Now, the feature that we're going to use to get the geometry off is called a spun profile. So we're going to go right here to spun profile. We're going along the x-axis because I have my parts situated on the xy right here, right in the upper left-hand quadrant is where we're going to be doing all of our work. Now, if you are just turning, so you don't think with the coordinates of x, y, z, and you think of it more as x and z, under the Home tab here, you can turn on turning mode. And what you'll see is down here at the bottom, the screen will change to Z and X instead of X, Y. So that's a good way of just keeping it in turning mode so you're always thinking with your Z and your X properly. I like to just leave it off because most of the stuff I do, I'm just drawing it in the XY plane, and when I machine it, it'll all be in the XZ plane anyway. So for me, the center line of the part is along the x-axis. So I want to go along the x for my direction. The tolerance is the allowable deviation. So it's kind of the quality of the part, and I'm going to leave it right there at 1,000. And then the origin is XYZ0, and I have my part centered right on that. So now all I have to do is drag a box over the whole part and then hit OK. And when I'm done, I can cancel out and then turn off the CAD layer over here. You're just going to click the eyeball, and I'm left with that geometry. So down the middle, we have a 1-inch hole, and then we have just some turn geometry and some grooves that we're going to have to cut in. So I'm going to start by going to my CAM tree. I'm going to right-click on CAM defaults and say New Job. And from here, I'm just going to choose Turning, which will choose the BC2X lathe. And I'm going to go to the Stock Wizard. Now for the Stock Wizard, I'm just going to hit Next. And so the way I like to figure this out, it does not automatically calculate a size of stock. So what I do is I look at my XY position. And if I bring my cursor to the back corner of the part, we can get a pretty good idea of how big this part is. So right here for X, we'll see it's 7.49. So it's about 7.5 inches long. And for Y, it's 3, but remember, this is just the radius. So the stock diameter is going to be closer to 6. So we'll say it's a 6-inch diameter, and we'll say that the length of it is 8.5 inches, just like that. Now, if we have material on the front face of the part that we want to take off, what we could do is right here where it says stock origin, we could put in, say, 0.1, and that's going to shift the whole stock forward. So it's still 8.5 inches long starting out, but we're going to take off that 100,000ths and then be able to do the rest of our cuts. Now, if we go ahead and hit the next arrow, this is where we set up our clearances for turning. We have our face at 1 inch, our diameter at 1 inch, and our internal diameter at 50 thou. So what that means is from the face, whenever we do clearance moves, it's going to go 1 inch away. From the diameters, it'll be 1 inch away, and from any ID work, it'll drop 50 thou and then come out. So when we're done, we can hit OK. And I have the setting on automatically that blanks out the stock. It's under the settings here. You go to settings, and then under system can go to CAM, and it's auto blank new items. It's going to blank out anything new that you create, stock, toolpath, all that stuff. So now I can actually get into the toolpathing part of this. But before I do any toolpathing, one of the best things to do is set up a tool crib so you have defined tools. So I'm going to right click on turning tools and say tool crib. And I'm going to start by clicking on Lathe Rough, and I'm going to add from my tool library. Now in here, I'm going to go ahead and choose just my CNMG with a 64th rad, hit OK, and there is the tool. I'm then going to go ahead and pick up a finisher, so I'll say add from the tool library. This time it's going to be a VNMG with a 64th rad, and again, I'll hit OK. There we go. And then we do need a center drill and a drill. So I'm going to do a center drill, add from the tool library. And I'm just going to use my 1/2 inch 90-degree spot drill, hit OK. And then for the drill, it has to be a 1-inch drill that I'm going to run through here. Just a quick drill. So I'll say add from tool library. Now the big thing here is the length. We need it to go 7.5 inches. So it's a pretty long way. And we might be boring that instead. I'm just going to drill it out, but we might have a smaller hole get drilled through and maybe bore to clean everything up. Maybe we hit it from 2 ops. But for now, I'm just going to say we're doing it with an extra long drill. And so I'm going to go down and find my 1-inch drill. There it is. We'll see the flute length on it is 6.375. So it's pretty close, but I can actually modify that now. So if I just double click on that tool, I could go in and say that the flute length is 8 inches and the protrusion length is 9 inches. So now I know I have enough to get all the way through. Now we also have our tool material. So if this is a high-speed steel drill, then you could leave it there, or you could change it to carbide or even an inserted drill. I'll just leave it on high-speed steel for now. And then I'm just going to click on the tool and hit OK. And there is my extra long drill. And then the last tool we really need to add is going to be the grooving tool. So I'll say groove, add from the tool library. And I'm just going to go ahead and pick my 1/8 inch wide OD groove here. Now, again, if we open this up, the one thing you want to pay attention to is if the depth of your groove, which we can't see there, if the depth of your groove is kind of deep, you need to make sure that the tool sticks out far enough to reach it. And you might need to get a custom holder for this. In this case, if I go to edit tool holder, I could see that the total length of stick out is 5/8 of an inch. This depth that I need to go for my groove is about 3/4 of an inch at the deepest point where we need to clear geometry. So I'm going to say that the stick out on this is actually 1 inch. So it just makes it stick a little bit longer. And then that way I don't have to worry about the tool hitting right there. So when I'm done, I hit OK. And then I'll hit OK once again. And now I have my grooving tool in there. So that should be all the tools we need. Now we hit OK. And then to get started, because I left that geometry in front of the part, we need this geometry here for Bobcad to recognize that there's material that needs to be faced off. So if I go to the machine setup and I right click, the first toolpath we're going to use is the lathe end face. So I'm going to pick that. Now where it says select geometry, you could go in and pick your geometry. With the lathe end face, you pretty much don't, but I do like to go in and pick a line. But if you didn't have a line that was right on the face, this is just recognizing the amount of material until the geometry starts. So anything in front of the part. So our rapid plane for multiple passes is going to retract to 200 thousandths. We're using the front face, which we can't change because this is a facing feature. And region 1 means we're going from the OD to the ID. Region 2 would let us go from the ID to the OD. So I'm going to go ahead and go region 1. I want to go from the stock, so it's recognizing the area of the stock that needs to be machined. And then right here we have extensions. Extensions allow us to start a little bit before the actual material and then kind of go past the center. So for the start, I'm going to go 1/8 of an inch. For the end, I'm just going to say go 1/16 of an inch past center so we can get rid of the little nub that's left at the end of the part. Next, we then have our machining strategy. Now, this is just a facing pass. I'm not too worried about the finish we get here. It's going to be pretty good, but I don't need to run a finish pass. So I'm just going to run the rough, which is the default. Right here for the posting page, we have separate moves or can cycles, and this just depends on your post processor. If you have can cycles defined through your post, you can feel free to run can cycles. Otherwise, just run separate moves, and it'll be separate moves through the code. Right here is where we get our tool. We'll see it's tool number 1, which is the CNMG. That's actually the right tool. That's the one I picked. We could show the tool holder to see what it looks like. And we could also modify the tool if we needed to. If we were maybe thinking we didn't want to use a CNMG, maybe we wanted a VNMG, we can change that right here on the fly. But since I already put one in my tool crib, I'll leave it there. The tool orientation, you have different orientations for how your tool sits. Now there's vertical, and then you have orientations 1, 2, 3, and 4. And then you have horizontal, which gives you 1, 2, 3, and 4. So if you're looking at these kind of things, like this would be good for an ID bore, to go in and clean up a bore on your ID. But for us, we're going to go with vertical, and we're going to go with orientation 1. Now right here we have our tool number. That's just the number that it is right now in the system. We can change that later on, but we're going to leave it right now. We got our spindle direction, clockwise or counterclockwise. our coolant type. So we have flood, mist, air, or oil. And then we have our feeds and speeds. We can go with either RPM or constant surface speed. So we'll go next. Here's the patterns. So there's kind of two patterns on here. You have standard and you have offset. Standard's going to start at the beginning and make a straight cut and then come back and make another straight cut. Offset is going to use the shape of the geometry for its cuts into the part. We also have some sorting options. So standard is going to keep everything moving in the one direction, and zigzag is actually going to zigzag its way down the part. This one you'd have to be careful with. You have to have the right kind of tooling to do that. So I'm going to go with standard and standard. And then right here for compensation, because I'm defining a tool and I'm not lying about the tool, I trust that the holder and the insert that I have selected are going to be the holder and the insert that I have at the machine. So what I can do is either apply machine compensation and apply G41 or G42 myself, or I can let Bobcad compensate for the tool by just saying on with collision detection. If I also want to avoid the holder touching the part, I can say use the tool holder. So I'll go ahead and say next. Right here for the parameters, we're just setting up our depth of cut, and I'll leave that at 50 thou, that's fine. And then right here we have our allowance that we're leaving for the finish cut if we were to do a finish cut. So this is the value we need to make sure is set to 0 so that we actually finish to size. Now right here we have no overlap selected on a face pass. I don't need these passes to overlap to where the previous pass was or a custom distance. When we do a turn rough and a turn finish, I will have them go to a previous cut so that we can knock the steps that are going to be left in the part down. But this is just a face pass, so we don't have to worry about that. We have our chip break settings, so it's based on either a length of cut, a set time, or a length of chip. And you could say every time we hit a 1/4 inch length of cut, retract to whatever distance we say, and that'll break the chip, and then you can continue cutting after that. I'm not going to use any chip break right now. Right here we have our corner types as round or sharp, and really this just changes how we interpolate the corner, whether we use a arc move in the code or whether we just do 2 line moves. I'm going to leave it on round. And then right here's an option called trim to stock. Now trim to stock is an option basically that allows you to bring in another stock model that may represent the geometry that's left after another job has already run. So maybe you've already turned this on a different machine. Something came up, you had to take the part off and run it on another machine. This would let you pick up kind of where you left off, but you would have to draw whatever result you still have. So if there's still material that you need to take off, you would need to draw that properly. Next, we then have our rapids page. So we have our default rapid on the approach and our default rapid on the exit. And that's a pretty good starting point for most things other than setting up your home position. But if you do need to take control, we have going from the ID, OD, or face clearances, as well as defined points. Same with the exit. Where do we return to? We can go to the tool home, the cycle start, or a defined point. Now you'll see this X-Z or Z-X or just ZX. What that means is X is going to move before Z, or Z is going to move before X, or it's going to be an angle out. So this is really the option that I change if I change an option on this page. And it's usually when I'm doing ID work because I want to ensure that I exit a little bit on my X, get in my rapid plane, and then go Z first, and then back out with X. So if I was on an ID bore, I would go with the ZX option. But in this case, I'll just say use the defaults. All the stuff we're working on is pretty much outside the part. Right here we have our leads. So we have parallel, perpendicular, horizontal, vertical, angled, or custom. And we have those same options for lead outs. And I try to avoid changing the leads if I can. If I see a problem with a lead when I run my simulation, I will come in and change them. But for now, I'm just going to run the defaults. And right here we have our advanced feeds. So convert rapids to feeds converts the G00s in the program for this tool path to G01 moves. So you don't dogleg rapid. And then we have lead in and lead out feed rate percentages. So a percentage of the cutting feed rate used just for leading in and leading out. And when we're all done and we can't hit next anymore, we're going to say finish. And there we have our facing pass. So now mine's already blanked out, so all I got to do is shrink it up, and there it goes. Now the next set I'm going to do is drilling the hole. I want to do that while I have all this meat on here. And so I just want to drill the hole down the middle. I'm going to right click on my machine setup 1 and go down to lathe hole. And then I'll select the geometry. Now all you're defining when you're drilling is the stop point. So I'm going to go back to here and hit OK. Now it doesn't care that it's on the x-axis at all. It's not reading the diameter. We have to tell it the diameter of the hole. So we're going to say it's 1 inch. Top of feature is at 0, or the front face of the part now that it's been faced off. And we want to go its total depth of 7.5 inches. Now right here we have our hole type, and if we leave it on through, we're going to add 50 thousandths to the depth of the hole to ensure that we go past the edge. Plus we're going to add the tip angle on. So right now the total depth is 7.5. When we see it on the drilling page, we'll see 2 other numbers. One is going to be 7.55, which is the added 50 thou, and the other one's going to be even larger than that. That's accounting for the length of the tip of the tool. So I'm going to leave it on through, but if you didn't want to add the extra 50 thou, leave it on blind, and I'll go next. Right here for the machining strategy, I'm going to go ahead and choose the lathe hole option, which gives me a center drill and a drill. But if I wanted to, I could also bore or ream this out. Right here we have our posting, again, separate moves or can cycles, just depending on your post. Right here we have our center drill. It's my 1/2 inch 90-degree spot drill. It's the tool that I picked earlier. We'll see it's tool number 3. We have our spindle direction, feeds and speeds, so we'll go next. Now for a center drill, you can choose either the depth you want to go, or you could tell it what you want the center diameter to be when you get to a specific depth. So I'm going to go in and say I want the center diameter to be 1/4 inch, which means I need to drill an 1/8 inch deep. And I could choose to peck this out if I wanted to. I'm just going to say single depth and next. And again, with the rapids, we have the default rapid on the approach and the default rapid on the exit. And again, I like to use the defaults. You might need to adjust the home positions for your tools, but try and use the defaults if you can. If you don't see any issues, it's probably good to go. Right here for the lathe drill, we got our 1 inch drill. It's the one that I changed the size of earlier, so we have enough length sticking out of it. We'll go next again. Now this is what I was talking about earlier. So the effective depth, the depth at which we are going to get a full 1 inch wide cut, is going to be 7.55. But the overall depth, and this is the number we're going to see in the code, is going to be 7.8504. And that's going to account for the 118-degree tip on the tool to ensure that we get an effective depth of 7.55. If you ever change this, you just uncheck the use cutting conditions and make your changes. Right down here, I'm going to go ahead and do a peck. Now, when we do our peck by default, up in the settings, we can actually change it under the cutting conditions, but there's a peck increment percentage, and it's a percentage of the tool diameter that's used to calculate the peck amount. In this case, it's set to 50%, so it's a 1/2 inch per peck. Next, we have our rapids, and I'm going to use my default rapid on the approach and my default rapid on the exit once again. When we're done, we can hit compute. And that one's going to be a quick one. There's our center drill. It stops just right there. And then we have our drill that goes all the way through the middle. Now the next one we're going to do is the outside cut here. We're going to rough all this in, but we're going to ignore the grooves because I want to do those as their specific grooving. So I'll right click on machine setup 1. We're going to go down to lathe turning and then select our geometry. And this is going to go from this front arc. So we want to click on that. And then we're going to go all the way back to this back line right here. Now, the way that we get these 2 clicks to chain together is by finding the midpoint on this final line and going past it. Then we can hold shift and click, and it'll chain select between those 2. In this case, we could have also dragged a box, but be careful dragging boxes because if there's any duplicate geometry, it will pick that and could screw up the toolpath. So we'll go ahead and hit OK. And then hit next. Right here for the feature, we have our rapid plane at 200 thousandths. We have our feature type, so we have a choice of OD, ID. We could do a front face or we could do a back face. Now the regions that are down below are kind of which side of the part are we working on, or really which direction is the tool facing. So OD1 is the orientation we need for our tools. But if I said region 2, then it would be taking my tool and flipping it 180 and coming in this way to machine that part. Same thing happens with the ID and as well as the front and back face. But for this one, we'll go with OD region 1. And right here we have undercuts. Now, undercuts are the grooves that are in the part. Now, a primary undercut is a turn groove. So this is telling Bobcat to ignore any turn grooves. A secondary undercut is face grooves. So this would tell it to ignore any face grooves. And if you have them both turned on, you're ignoring all grooves. Now, since this is kind of my initial rough pass for most of the material, I tell it to go from the stock. So it recognizes where there's stock around the geometry that I selected. Right here, we have some extensions. So again, extensions allow us to start a little bit before the part and a little bit after the part. So for my distance on this, I'll go with an 1/8 inch before. And I'm just going to do a 1/4 inch after, because that's going to allow me to get a better cutoff later on, which I didn't add to the library, but that's a pretty easy tool to pick. Right here for the strategy, we're going to go ahead and choose the rough/finish option, which is going to allow us to rough the part and finish the part. So we'll go next. Posting, again, separate moves or can cycles. For the tool, we're going to use that CNMG, the original tool we used, so tool number 1. We'll go next again. For the patterns, we have our standard cut or the offset cut. This is the same exact tool path as what we got when we saw the facing portion of the video. So I'm just going to go and say on with collision detection, but use that tool holder so I can avoid any collisions. For the parameters, I'm actually fine. I'll do 50 thousandths for the depth of cut, and 10 thousandths is what I'm going to leave for the finish pass. Now again, the overlap amount is where we overlap to after we finish our cut. So we're going to finish a cut, and instead of it actually leading out right here, it's going up and leading out at the previous cut so that we can get rid of any steps that are left on the part. Other than that, we have our corner type, our chip break, and our bounds. No changes there. For our rapids, again, I'll just use the default on the approach and the exit. For the leads, I'm just going to go with a parallel lead in and an angled lead out, and I'm fine with the 100 thou distance and the advanced feed. So again, convert rapids to feeds or change your lead in and lead out feed rate percentages. Now for the finish tool, you'll see it automatically grabbed my VNMG, and that's because that tool is in the system. I put it in there myself so it knows that it's there. Right here for the patterns, we get 2 patterns for this finish pass, which is a continuous cut. So it's going to start at the beginning and machine all the way to the end. We also have alternate, which gives us 3 options. The first option would be face vertical only. So this is going to go in and just face the vertical pieces of geometry, which isn't much on this part, but it's facing them backwards. So it's dragging down, to eliminate that rat's nest that can build up. We also have turn diameters only. So it's going to go from the front to the back in the normal direction, but only on the turns. It'll actually ignore any of the vertical cuts. Or you can do both, and it breaks it into each individual segment. I'm just going to go with a continuous finish, and I'm going to say on with collision detection using the tool holder. For the parameters, there's not much to do here. We just have a finish allowance, and this would be if we were going to come in and finish this again, then we'd set up a little allowance to leave material. Other than that, we just have the chip break, the corner type, and the bounds. No changes there. For the rapids, again, no changes. Leads, go with parallel and angle once again. And then the advanced feeds. So convert rapids to feeds, lead in, lead out, feed rate percentages. When we're all done and we can't hit next anymore, we're going to hit compute. And so there is the rough pass. So it's going to go in, just take a bunch of material out there. And then we have our basic finish just going in, making that cut. So now I'll go ahead and shrink that up. Right click on machine setup 1. And we're going to go ahead and choose a lathe groove this time. So for the geometry on this one, you can actually drag a box, just don't drag too much of a box. I only need to drag a box that starts about here, goes across the whole part, down to cover all that. We don't want to select the geometry that's connecting them together. So we'll go ahead and hit OK, and then go next. Right here for the feature, we have our OD region 1. And if your tool and your groove are on a specific angle, you can actually set the grooving tool to that angle, and then you can tell us what the angle is, and that way we know to go into that the right way. Now for the constraints, from stock would start it at the original stock height. So we'd be starting all of our grooving from here, but all this material's gone. So from geometry goes from the height of the highest point of the geometry selected and then cuts its way in. I'm not going to do any extensions on the groove this time. Right here for the strategy, we'll go with the groove rough finish. Right here's our posting, again, separate moves or canned cycles. Right here's our grooving tool. So I like to turn on the tool holder, make sure it looks right. And if you're not sure, go up to the tool crib, go to groove. If you've set up a tool, it's going to show up in here. You could also use your cutoff tool if you wanted to. So I'll go ahead and hit OK and then next. Right here for the patterns, we could choose either a standard cut where we basically cut as many times as we need to cut it out. Below here, we have our sorting, and this all goes towards standard. So it's kind of what order do we go in? Do we just make one cut and then move just next to that and next to that, next to that, and keep moving? Or do we go center out? So we start with the center of the groove and then work our way out from there. Center out alternate is going to do kind of the center and then one side and then back to the other side and then back to the first side and then back to the second side, just depending on how many cuts you have. And then skip is actually going to skip one. So we're going to make our first cut, we're going to skip a pass, we're going to make our second, skip a pass, third, and then go back and clean up the areas we skipped. We also have single pass, which allows us to go with center, beginning, or end, and all these options are used for if you had a single press kind of groove where you're just using a tool that has a specific shape that creates the groove that you need, just presses in and then leaves. And then we also have zigzag, so you can zigzag your way down into there. I'm going to go with standard and standard sorting. And for the collision checking, I'll tell it to use the tool holder. We don't have the whole compensation for this one. Right here for the parameters, we have our step over. I'm going to set it to a 50% step over, so just a 1/16 of an inch. Right here's how much material we are leaving for the finish pass to clean up. And if we wanted to do multiple depths, we could go in and tell it what the depth of cut is per pass. We can also peck our way out with this. So we can actually peck all these grooves in. And all we have to define is the first peck amount, the peck increment, and the peck clearance. But I'm not going to peck. And next. Rapids, once again, I'm going to use the defaults. Because this is a roughing groove and it's not actually moving along the Z, it's just plunging in X and then moving over in Z, but never inside the part. It's just parallel lead-ins and lead-outs and advanced feeds. No changes. So for the other groove, again, tool number 5, that's the correct tool. That's the one we want. So we'll go next. For the patterns on this, we have forced down cutting where we hit the groove from both sides. So we're going to come in from the left and the right and kind of meet in the middle unless we overlap them. Or we could just do a basic finish where we cut in one direction. Now this one does have system compensation, but it's already on with collision detection. We're just going to tell it to use the tool holder as well. For the parameters, no finish allowance, no corner type change, no trim to stock. Rapids, once again, just use the defaults, leads, defaults, and advanced feeds. I'm going to leave them there. So from here we can hit compute, and there is our groove. So there's our groove rough going in and roughing the whole thing out. And then we have our groove finish going in and finishing that. So the last thing we now need to do is do a cutoff. So we're just going to start by right-clicking on Machine Setup 1, go into Lathe Cutoff. I'll select my geometry. And just like drilling, all we're really doing is picking a point for this. So I can pick that point and then hit OK. So it knows where the back of the part is. Right here's our feature page. So we have our 200 thousandths rapid plane. It's an OD feature. Now, for the constraints on this one, it could be a little bit different. Instead of going from the stock, because if you remember, we went and took an extra 1/4 of an inch off after we finished the rough. So we technically have a 1/4 inch extra that's finished to this length here. Now, if I was to say custom, I can actually come in and tell it where to start from. So I can pick that line and hit OK, and now it knows where it needs to come from. Now, we shouldn't have any extra stock anyway because I didn't make the stock any bigger. I'm just going past. If we were to start with a piece of stock that was, instead of 6 inches, it was 6 1/4, then this would start at 6 inches instead of at the stock diameter. But in this case, the numbers are going to be the same. For the machining strategy, we're just going to do a cutoff. For the posting, you got separate moves or canned cycles once again. For the cutoff itself, if we show the tool holder, we can make sure we get the right tool, which we can see this is way too short. So if I go up to my tool crib and I go over to cutoff, I could say add from the tool library, and we'll see we have this 3 1/4 inch cutoff tool. So it's a lot longer. So I'll hit OK. That's the tool we want. And so we'll hit OK again. And there it is. Next, we have our parameters. So it knows what distance back in Z we want to cut off, which is at 7.5 inches. But we'll see right here for the X, it's stopping a little early. It's not going all the way down. And so what we can do with this is we can actually set this to 0 so that it cuts all the way down to the center. But remember, we do have a hole, so this is going to come off as soon as we hit that point right there. We could choose to give it a corner break as well. Right now it's turned off, and according to the part, it is a sharp corner on the back. But we could tell it to chamfer the corner. We could define the length of it as well as the angle. And we have our fillet option as well. I'm not going to run either of those. We could also use this for pecking. But again, no pecking, so we'll go next. And the rapids, just going to use the defaults. So we can hit compute, and there is our cutoff. So now that we're all done, the best thing to do is save. So I'm going to do a save as. I'm going to save as that part there and say save. Yes, replace it. And now we can go ahead and check it out inside the simulation. So we'll go up and hit start simulation. And when the simulation loads, I like to set it to a front view and then set your speed so it's not going too fast. The lathe does run fairly quickly through the simulation here. So I'll go ahead and say run, and it's going to face off the part. And if we want to turn off the tool path, we can go to visibility and turn off the path so we don't have to see it at all. We'll see it's just going to turn this down. I'll speed it up just a little. There's our rough. There's our drill. There's our finish. And then we have our finish for the groove. And then there is our cutoff. So there's our full part. And now what we can do, if we want to get rid of this back piece that's sitting here so we could really look at the full part, we could actually go to the measure tab, change it from points to remove chips, only keep one part. And then we're going to click on our model, but we're going to click with our middle mouse wheel like it's a button. And it's going to remove the excess geometry that's no longer connected to the stock. And there we have it. When we're all done, we can close out of the simulation. And then the biggest thing is make sure you have the correct post processor here, because that's going to control everything, especially the CAN cycles. And then right up here, we can hit the post option, or this little button here, or the big button up top that says post, and the code is going to show up there. From here, we can right click and say save as and save it, bring it out to the machine, or we could bring it to the NC editor to make changes to it if needed, and then resave it, or send it to the machine via RS-232. And that concludes the video on the lathe tutorial from inside of Bobcat Cam.